Assalamualaikum and hi, I wish to all panels. My name is Amirul Aiman bin Razman and I am a student under the supervision of Dr. Mona Riza binti Muhammad Esa. My FYP title is Temporal and Wavelet Analysis carried on narrowed bipolar pulse and return stroke recorded in Malaysia Thunderstorm. My intention of recording this video is to show you how the analysis was conducted to gain the temporal characteristic as well as wavelet characteristic of the lightning waveforms. To start off, I would like to show you how the lightning waveform is determined. There are 4 types of lightning that I use to do the analysis. The first one is narrow positive bipolar pulse. So this is the shape of narrow positive bipolar pulse. Second one is narrow negative bipolar pulse. So this is the shape of narrow negative bipolar pulse. The third one is negative cloud to ground lightning. So this is the shape of negative cloud to ground lightnings. And lastly is positive cloud to ground lightning, and this is the shape of the lightning that I have mentioned. So how I do the analysis is by using Picoscope software. So Picoscope software enable me to see the characteristic of the lightning waveform in time domain. So I use this marker down here to mark the starting point of the lightning waveform. So this is approximately the start and the end of the lightning waveform. So as I explained previously, so this is narrow positive bipolar pulse. So the characteristic that I would like to see in temporal analysis is the first one, pulse duration. So pulse duration is the time taken from the starting point to the ending point of the lightning waveform. So this waveform has approximately ended here, and it shows the difference between these two lines. So the difference is around 16.46 microsecond. Okay, so the next characteristic that I would like to see is the rise time. So the rise time that I pick here is 0 to 100 maximum level. So the time taken, the difference between these two lines is 1.883 microsecond. Okay, the third one is the zero crossing time. So zero crossing time is the time taken for the pulse duration to cross over with the zero line. So here is the duration where the waveform firstly crossing over the zero line. So it takes around 3.069 microsecond. And lastly, for the full width half maximum, some calculation has to be done here. So looking at this blue marker, blue line, okay, the difference between these two lines is 2.893 volt. So to get to the middle, to the half of the lightning waveform, we must divide it by 2. So 2.893 divided by 2 will get around 1.4465. So 1.4465 is around this level. 1.4465 is around 1.45. So this is approximately the middle part of the lightning waveform, lightning impulse. So this is the time taken, the range is the time taken for the full width half maximum to happen. So here is around 1.9 to 1.29 microsecond. So that is how temporal characteristic was determined using picoscope software. So for the other types of lightning, the same procedure will be repeated to gain the characteristic in temporal. Next is the wavelet analysis by using MATLAB software. Okay, the first section show me the uploading of the picoscope data. So firstly, I load the picoscope data, which is for this case is ref underscore 888. Okay, and since I want only channel A to be used and analyzed, I will clear other channels such as B, C, and D before plotting uh, X and Y axis. Also, there is zooming properties that enable me to precisely choose the right starting point. Okay, so X is equal to least space here, means that for a total duration of 0 until 2 seconds, there are 5 million interval, so that it will be more precise and can analyze and the analyzation can be done precisely. Okay, so after running the first section, it will show me this kind of graph. Okay, and I want to select the starting point to be around this level. Okay, so this level holds value of x 0.29999. So I take this value and put into the next section here. So the Muller here is the starting point. It's the starting point of the analyzation of, I mean, the window size. Okay, the starting point of the window size. Okay, I want the window size to be only 50 microsecond. So I set it to be 50 microsecond only. Okay, this 125 value is obtained by dividing 50 microsecond to the sample rate of the picoscope data, which is around 400 nanosecond. So this 125 value helps me to set the reference line. So meaning that I want a reference line to be set 0. I want a reference line to be set 0 so that I can see the bipolar pulse, okay, the crossing over and etc. Okay, so I will plot the data, and also the title here is narrow negative bipolar pulse. Okay, moving to the last section here is the wavelet analysis. Okay, so by running full, I can show how the wavelet analysis characteristic data be extracted. Okay, so by running full of the coding, as you can see here, I have this one picture, okay, showing me the time domain picture, and also the frequency domain picture. So what I want in wavelet analysis is the spread region, the spectral region, and maximum power spectrum. Okay, so in this picture, you can see there are two regions, which is the first region is the initial region, and the latter one is the overshoot region. Okay, so these two regions have a spectral value and also spread region. Okay, spectral is the light blue color area. So I will show you like this. It will be easier to see. So this area to this area, okay, is the spectral region of the initial part. And then the high density color, which is yellow, and this level up to this level is the region of the spread region. Okay, the same things applies to the later stage, the overshoot stage. Okay, the spread region is the light blue color. So the light blue region is around this level up to this level. And also the spread region is the most concentrated color in the middle, which is around this level up to this level. Okay, so after getting know all of the things that I want to see, I can get the value. Okay, for example, the maximum power spectrum is 6.04, stated here, 6.04. Okay, 6.04 is on the overshoot stages, overshoot stage, which is around this level. Okay, 6.00 something. Okay, so the peak power spectrum is in the overshoot stage. Okay, so as you can see here, the Y value is 110. So the 110 indicates the frequency of that particular point. Okay, so by clicking on F1 here, I can see that 110 is around having 52.52 kilohertz value. Okay, meaning that at this particular point, I can see the value of the frequency is 52.52 kilohertz, and the power spectrum is 6.008. Okay, so by extracting one by one according to the criteria, the wavelet analysis is repeated, okay, to another types of lightning such as narrow positive, negative CG, and positive CG. Okay, with that, thank you for listening to my presentation on how the analysis was conducted.